In this lecture, we will see square root decomposition. Given an array, we have two types of queries. Generally, what happens is, first query is like I want to update I index to a value k. The second type of query is I want to apply operation on the range. For example, I want to get the sum from L to R. If we use only the array and we use the brute force method, what will happen is this updation will take order of one time, since we can directly go to that index and we can update that. And this sum, because we have to run a loop from L to R, it will take in the worst case order n. And suppose if I have q queries, then the time complexity will become q into n. And suppose that my upper bound for q is 10 to the power 3 and n is 10 to the power 9. So this will become 10 to the power 12. It means for a computer to solve this many queries, it will take 10 to the power 12 by 10 to the power 9. It means 1000 second approximately, if it is solving 1 billion operation per second. Now we can modify this. What we can do is we can create a sum array. We can create a sum array in which what will happen? We will create another array of same size. Suppose this is our original array which contain our array 524 9 7 6 3 1, and then we create a sum array of same size. Now this array will contain the sum from, at any index it will contain the sum from initial to that position. So this will contain 5, then this will contain 5 plus 2 which is 7, then this will contain 7 plus 4 which is 11, then 11 plus 9 is 20, 20 plus 7 is 27, plus 6 is 33, plus 3 is 36, plus 1 is 37. So now if I want, suppose sum from 2 to 5, what will I do? Subtract 1 from this lower limit, so it will become 1, and we will do ARR of 5 minus ARR of 1, or let's say I'm naming it sum array. So sum of 5 minus sum of 1. So sum of 5 is 33 minus sum of 1 is 7. So 33 minus 7 is 26. So the sum from 2 to 5 is 26. You can see also 4 plus 9 is 13 plus 7 is 20 plus 6 is 26, like this. Now the range query will become order 1 and the update will become order n. Why? Suppose I have updated this 4 to 7. Then I have to update all the sums after this. So in the worst case, 0 gets updated and I have to update all the sums after this. So it will take order n time complexity in the worst case. Again, if we have q queries, the total time complexity will become q into n. So we have not that much modified our, made our approach. So we have not that much made our approach efficient, because this q query can be any of this. So all the q queries can be updation, or all the q queries can be just finding the sum. So what we can do is we can use square root decomposition, and in square root decomposition what we will do, suppose we have the array, the size of the array n equals to 8. So we will find the square root of n. So square root of n and ceil of this is 3. So we'll divide this into 3 parts of 3 blocks each, right? So this will become 5 2 4, the next block will become 9 7 6, and the next block will become 3 1. Now there is an empty cell here. What should I put here? So what happens is that actually when we are doing this, we don't need to store these blocks. We only need to store the results of there, right? So here we are calculating sum, so we can assume that this is 0. If we are calculating product, then we can assume that this is 1. But when we are coding, we are not storing these blocks. So what will be the sum here? 5 plus 2 plus 4 is 11. 9 plus 7 plus 6 is 22. 3 plus 1 is 4. So we have stored the sum here. And now what happens is that whenever someone tells me, okay, I need to update this 4, index 4 to 10. So what I have to do, I have to update index 4 to 10. What will I do? Because I am only storing this thing, and how to calculate in which block which number is there, we will see in a moment. But let's see that I have to update 10, index 4 to 10. So how much value I have to change? So it will be 10 minus 7, which is 3. So what I will do, I will change it to 10 and I will add 3 here. So if I add 3, it will become 25. Okay, so 1 is here, and I'm telling you right now that from any index I can go to its block in order one time, right? So what happens is that I can update that value directly in order 1. So updation is order 1. Now what about range queries? Suppose I tell you that I want sum from L to R. What happens is, if we leave the block in which L resides and if we leave the block in which R resides, okay? So suppose L is 2 and R is 6. So 2 resides in this block, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 2 resides in this block, so we can leave this block. We will not consider this block. And 6 resides in this block, so we will leave these blocks as well. What we will do, we will sum all the remaining blocks. So all the remaining blocks, there may be more blocks here. So right now there is only one block. So sum is 25. Then what we can do is, from L to this block's end, so L is 2 to this block end, this is the end, I can add this, so it will be 4. And similarly for the R till this block starts. So here till the values in this block only, it means that only this 3, because only this 3 is in this block before this. Okay, so if it is 7, then I have to add 6 and 7 index both, so it's 3 plus 1. So right now it's only 3, so plus 3, so the value is 25 plus 7 is 32. And you can see also 4 plus 9 plus 10 plus 6 plus 3 is 32. Okay, now how to calculate which index is in which block? So we know that our block size is root n. So our block size is equals to square root of n, right? In this case it is 3. So when you divide index by block size, you will get to the index of the block array. So if here 0, 1, 2 belongs to 0th block, right? So if you say 0 divided by 3 or 1 divided by 3 or 2 divided by 3, it is integer division. In all the 3 cases you will get 0. Or if you do 3 divided by 3, 4 divided by 3, 5 divided by 3, in all these cases you will get 1. And you can see 3, 4 and 5 belongs to block number 1. And similarly 6 divided by 3 or 7 divided by 3, you will get 2. So here you can go from index to block directly, right? So this is the formula to go to index to block. And here also when we are calculating this, we can just loop from L till we are getting in the same block. So I equals to L, we can start from here. Then we will see L divided by root n if it is same as starting block. Okay, how can we calculate starting block? Starting block is L divided by root n. And similarly, we can calculate the end block, R divided by root n. And we will do this if I equal start block, we can add it to the sum and we will do I plus plus. And if this is like, let's say I equals to R, we can start from I equals to R. And if I divided by root n equal end block, what we can do is we can just add this to the sum and we can do I minus minus. So what we are doing, from L we are going till we are in the same block. So what we are doing is, we are not adding the whole block here, we are only adding some values, right? If I have started from index 2, so I am only adding this. If I would have started from index 1, I would have added this, right? And if I am starting from 6, then I'm going to I minus minus till I am in the same block. So for example, if I've started from 7, I'm in the end block, yes, so I will add 1 to the sum, then I will do I minus minus, so I will come to 6. I'm in the end block, yes, so I will just add this 3 to the sum. I'll do I minus minus, I will come to 5. Am I in the end block? No, I'm not in the end block. So I'll just break the loop there. What will be the time complexity of this? So number one thing is, how many blocks will be there? So if we see n divided by root n, so we will have root n blocks. So this will be square root n blocks, right? Except for the starting and ending block. Starting ending means start block is where L resides and end block is where R resides. So except for these two blocks, what we are doing is we are adding root n blocks. Okay, root n minus 2. So in time complexity, it is root n only. Plus, we are searching in the block in which L resides. So how many elements are there in which L resides? So there will be at max root n elements only. Why? Because we are dividing this into root n parts. So it will be at max root n elements there. So we have to search at max root n element plus the number of elements in which R resides will be root n. So it will be big O of 3 root n for range query or big O of root n. And if we have Q queries, then the time complexity will be big O of Q into root n. Okay. Now if we see if Q is 10 to the power 3 and n is 10 to the power 9, so root n will become 10 to the power 3. So this will become 10 to the power 6. Okay. And if we divide 10 to the power 6 by 10 to the power 9, we will get 10 to the power minus 3. So the queries which were taking 1000 seconds now will take only 1 millisecond to execute, right? And the code is also so simple. Let's see the code. So here I have included some files which I require. I have included CMath because I require ceil function and square root function. Then using namespace std, and now we will start with the main. Okay. First I have defined some variables whichever I am using. Then I am taking input on number of elements in the array. Then I am creating a new array of that much size and I am taking each element in the input. Then what I am doing is I am creating blocks using square root decompose function. Now comes to square root decompose function first. What it is doing is it is actually creating the blocks which we have created. So given the array, so it was creating some blocks. So whatever the sum in that block, we are seeing only that. Okay, so these blocks will contain the sum. So we have initialized the block size to n by square root of n and ceil of that. And then we have created a new array with that much block size. And for I equals to 0, I less than n. So we are iterating over the array. And if what we are doing is I divide by block size. So that we can go to the block index. So I divide by block size gives us the block index of ith index of the array. So what we are doing is I divide by block size plus equals to arr I, right? So it is by default initialized to 0. Then we are returning the blocks. Okay, so this is what square root decompose function is doing. Then we are inputting the number of queries the user has to input while q minus minus. Then we are taking the type of the query. So 1 means update and 2 means range sum. On the type, we are creating a switch case. Case 1, we have to take the index and key from the user that he wants to update. Then we will call update arr blocks and index and key. Okay. So here we have to update arr of index equals to key. Let's see this update function as well. So here we have created the update function. Now I am calculating the change value. So change value will be new value minus old value. New value is key, old value is the value that is there at that array. And then I will update the arr index equals to key. Then I will calculate the block size, ceil of n by square root of n. And then I will go to that block size and I will add the change value. For example, if I am changing from 5 to 10, it means that I have to add 5. So this change value would be 10 minus 5 equals to 5 and I'm adding that. Okay. And if I am doing from 10 to 5, so what happens is the old value was 10 and new value is 5. So I have to reduce 5 from the sum. So this key is 5 minus 10 is minus 5 and I'm adding minus 5. It means it is reducing it by 5. Then case 2, we will take input L and R from index L to index R. And then we are calling calculate sum, which is printing the sum. In this, we are passing arr blocks and left and right. Here, again, we are calculating the block size. So you can make it global, you can calculate it again, or you can pass it in the function itself. But what I am doing is, it is easier to calculate, not much complexity in this. So that is why I am just calculating it again and again. Then I will calculate the start block, which is L divided by block size, and end block, which is R divided by block size. After that, what we will do, we will run the loop from start block plus 1, because we are not calculating the sum of start block, and we will go less than end block and I plus plus, and what we will do, we will do sum plus equals to block I. So except starting block and end block, we are just adding the blocks and we are putting the sum in the sum variable. Then what will I do? I equals to L. Now while I divide by block size equal start block, it means till I am in the start block starting from L, what I will do, I will add the array index to the sum. So ARR I plus plus will be added to the sum, and then I will make I equals to R, and similarly when till I am in the end block, I will add that element to the sum and I will do I minus minus. So what I have done, I have added the blocks. It means all the elements between L and R's block are added. So it will be in sum. Then all the element from L till that block ends, till the start block ends, is added to the sum, and all the elements from R till the end blocks end, we are putting that into the sum. Now we have all the sum, so we can just return the sum and it will print the sum here. Okay. Now you must be wondering that we are calculating square root decompose here and it is taking order of n. Yes, it is taking order of n, but it is only calculated once. It is not calculated for every query. So it will be n plus q into square root of n. Okay. So this is only effective when we have number of queries instead of just asking once or twice. If you are asking once or twice, then I guess we can do it in brute force manner only, which is more efficient than creating this blocks or doing square root decomposition. Let's run this code. If you see, this is the same code that I have written there. Let's compile it, run it. So I'm taking the same array which I have taken for the example. Now let's take 5 queries. Now we will enter 2. 2 is the type of query. It means it is range query. Then we'll take the sum from 0 to 7, which was 37. So it is showing 37 sum. Now we can update. So query type 1, let's say index 4 to 10. So index 4 is 7. So I'm updating it to 10. Now the sum from 0 to 7 should increase by 3. So let's again check it. Yes, it is 40. Let's check another limit. Let's say sum from 3 to 6. Okay, so this was updated to 10. So it would be 9 plus 10, 19 plus 6, 25 plus 3 is 28. And in this manner, we can check any other range also. And you can see that the answer is correct. So this is how you do square root decomposition. There are basically square root decompose function which creates a block, and then we have update and calculate some function. You can change this program to calculate the product between two range also. Try to do that. Thank you.